As we do projectile problems, we're going to have to know how to deal with the x and y components of that motion because a lot of projectiles will have both motion in the x direction and motion in the y direction. So we should talk about how to handle each of those separately. So we'll do two short videos. One will be on how to handle the y component, and the other will be on how to handle the x component. And we'll use this projectile shot off of a cliff right now, although these formulas will work for just about any projectile problem. So let's deal with the y component. And let's figure out how to do the y displacement. How high is the projectile going to go in the y direction? And how do we use this formula, which is a really basic formula we talked about in linear motion, to just deal with that y component? So let's just rewrite the formula down here. Now, in the case of the projectile coming off of a cliff, thrown completely horizontally, we're going to have, for the y direction, no initial velocity. So we're just going to cancel that out because all we care about is this y component. We don't care about the x component at all. And so we're just going to deal with this object. If it's thrown straight out, it's going to fall. So we don't have an initial velocity in the y direction, which really just leaves us with this distance equals 1/2 at squared. Let's do a little substitution or changing of our variables to make it match what we're doing. That distance is going to be in the y direction. And it's going to be 1/2. And then a, in this case, is going to be gravity. So let's change that a to g and make it specifically 9.81 meters per second squared, and then times t squared. And if you want to know the y displacement of that object, right there you have it. You can just take y equals 1/2 times gt squared. Now, we also need to know how long that object is going to be in the air, because how long it falls is going to affect how far it can go out, because it can't go in the x direction once it hits the ground anymore. That'll tell us how far it's going to go. So when we want to know, we need to know that time component. Well, it's as simple as rearranging this formula right here, y equals 1/2 gt squared. So I'll summarize it for you right away. You're just going to end up with t equals 2y over g, and you take the square root of that. I'll just show you that calculation here if you want to follow along for the algebra. I'm going to isolate my t, so I'm going to take this times 2 on both sides. That's going to get rid of my half there. That's going to give me 2y equals gt squared. I'll divide by g on both sides, and then I'm left with, and if you'll allow me to flip this, t squared equals 2y over g, and then to get t instead of t squared, I'll take the square root of this and the square root of that, and I'll get t equals the square root of 2y over g. Okay, so for an object thrown horizontally from a cliff, we start with our distance formula that involves an initial velocity and acceleration. If we want to know the y displacement or the vertical displacement, we know that I don't have any initial velocity in the y direction, so that completely goes away. If I solve this so that gives me my y displacement. And then if I want to know how long that thing is in the air, I just simply rearrange it for time. And it's important to remember, when we start to deal with our x component, then we already have a formula for time, and that time is the same for both the x and y components. So as we go to calculate our x displacements on this, we can use this time formula right here.